Imagine the brightest light you have ever seen. Now imagine that light multiplied by 70. That's how bright GRB 2210009A was. This explosion was so powerful that it could have been seen with the naked eye from Earth if it had been closer. Welcome to Luminary Cosmos, where we explore the amazing mysteries of the universe. And today we have a very special episode for you. We're going to talk about the BOT, the brightest cosmic explosion of all time. Yes, you heard that right. The BOT is the name given to a gamma ray burst that occurred on October 2022 and was detected by several satellites in space. Gamma ray bursts are the most powerful explosion in the universe, usually caused by a collapse of massive stars into black holes. But this event was unlike any other gamma ray burst observed before. It was so bright and energetic that it effectively blinded most gamma ray instruments in space. It also lasted for much longer than usual and had a unique jet structure that shaped its afterglow emission. And to top it all off, it produced an amazing effect called light echoes that made it visible for months after its discovery. In this episode, we're going to dive deep into the bird and learn more about what made it so special, how scientists studied it, and what we can learn from it. So buckle up and get ready for cosmic adventure. Make sure to watch this video till the end and hit the subscribe button. Let's begin. Before we get into the details of the bird, let's first review what gamma ray bursts are and how they are produced. Gamma ray bursts, or GRBs for short, are flashes of high energy radiation that can be detected from billions of light years away. They are the most energetic events in the universe, releasing more energy in a few minutes than our sun will in its entire lifetime. GRBs come in two types, short and long. Short GRBs last for less than 2 seconds and are thought to be caused by the merger of two compact objects, such as neutron stars or black holes. Long GRBs last for more than 2 seconds and are thought to be caused by the collapse of massive stars into black holes. In both cases, the formation of a black hole is accompanied by the launch of a jet of material at near light speed into space. This jet produces gamma rays when it interacts with the surrounding medium. The jet also slows down over time and produces lower energy radiations such as X-rays and radio waves that can be observed for days or weeks after the initial burst. This is called the afterglow emission. GRBs are very rare events. On average, only one GRB per day is detected by satellites in space. Most GRBs are very faint and distant, requiring powerful telescopes to study them. But every once in a while, a GRB is so bright and close that it can be seen with the naked eye. One such example was GRB 080319b, which occurred in March 2008 and was visible from Earth about 30 seconds. It was so bright that it could have been seen from Mars. It was also one of the most distant GRBs ever detected, originating from a galaxy 7.5 billion light years away. But even GRB 080319b pales in comparison to the BOT. The BOT was first detected on October 9, 2022 by several satellites in space, including NASA's Fermi Gamma Ray Space Telescope and Niels Gehrels Swift Observatory. It was immediately recognized as an exceptional event. It had a peak brightness of about 10 into 54 ergs per second, which is about 70 times brighter than the previous record holder. It also had a total energy output of about 10 into 56 ergs, which is about 100 times more than a typical long GRB. The boat was also very long lasting. It had an initial duration of about 10 minutes, followed by a prolonged afterglow emission that lasted for months. Most GRBs fade away within hours or days after their detection. The boat originated from a distance of 2.4 million light years away, which is relatively nearby for our GRB. But even when accounting for relative distance, the energy of the event and the radiation produced by its aftermath were off the charts. It is decidedly not normal for a cosmically distant event to deposit about a gigawatt of power into the Earth's upper atmosphere. So, what made the bot so bright and persistent? To answer this question, scientists used NASA's New Star Observatory, a nuclear spectroscopic telescope array, and other X-ray telescopes to study the afterglow of the bird. NuSTAR is a unique instrument that can observe high-energy X-rays that are usually blocked by Earth's atmosphere. It can also measure the polarization of X-rays, which reveals information about the magnetic fields and geometry of the source. Using NuSTAR and other telescopes, scientists discovered that the boat had a unique jet structure that shaped its afterglow emission. The jet had a narrow core with wider sides and variation in energy depending on the distance from the core. This means that observers at different angles will see different brightness and duration of the burst. The jet structure could be influenced by the properties of the progenitor star, such as its mass, rotation, and magnetic field. It could also indicate a different mechanism for launching the jet, such as a rapidly spinning black hole or a neutron star merger. The jet structure also affected the polarization of the X-rays. The polarization was very high near the core of the jet, indicating a strong and ordered magnetic field. The polarization was lower near the edges of the jet, indicating a weaker and more chaotic magnetic field. Polarization also changed over time. As the jet interacted with the surrounding medium, the polarization decreased as the jet slowed down and became more isotropic. The polarization also increased when the jet encountered a defense shell of material that was ejected by the progenitor star before its collapse. The jet structure and polarization of the bird provide valuable clues about how GRBs are produced and how they evolve over time. But they don't explain why the bird persisted for so long. To explain the persistence of the bird, scientists invoked an effect called light echoes. Light echoes occur when light from a source is reflected by dust layers in space. The reflected light reaches us later than the direct light, creating an extended image of the source. In the case of the bird, the dust layers located in our own galaxy, about 10,000 light years away from us. The dust layers acted like mirrors, reflecting and scattering the X-rays from the bird. The light echoes amplified and prolonged the afterglow emission of the bird, making it appear brighter and longer than it actually was. Scientists used NuSTAR and other telescopes to measure the time delay and distance of the dust layers. They also used computer simulations to model how the light echoes changed over time. The light echoes not only explained the persistence of the bird, but also provided a unique opportunity to study dust properties in our galaxy. By analyzing how the dust reflected and polarized the X-rays from the bird, scientists could infer information about the size, shape, and composition of the dust grains. The light echoes also allowed scientists to measure distance and map dust structures in our galaxy. By comparing how different telescopes observe different parts of the light echoes, scientists could triangulate their positions and create a 3D map of the dust layers. The light echoes were like a cosmic gift that kept on giving. The bird is a rare and remarkable event that challenges our understanding of GRBs and their jets. It also provides a unique opportunity to study light echoes and dust properties in our galaxy. By observing and analyzing the birth, scientists can learn more about how GRBs are produced, how they are evolved over time, and how they affect their environments. They can also use the boat as a probe to measure distances and map dust structures in our galaxy. The boat is not only a cosmic explosion like no other, but also a valuable source of information for astrophysics and cosmology. That's all for this episode of Luminary Cosmos. I hope you enjoyed learning about the bird, the brightest cosmic explosion of all time. If you did, please give us a thumbs up and subscribe for more episodes like this. And don't forget to share your thoughts and questions in the comment section below. See you in another fascinating discovery of the universe. Till that, take care, love you, goodbye.